Hello friend, I hope you have watched my previous tutorial and enjoy. In this tutorial I am with a question which is from thermodynamics and based on energy interaction. So before going to solve this problem, I want you note down this problem because it is one of the most conceptual question of thermodynamics. So I hope you have note down and keep watching till the end. At the end you will definitely able to solve this problem with very easy. Here, first we understand what is given in the question and what we have to find. In the given question, there is a spherical balloon of 1 meter diameter contain gas at initial pressure of 150 kilopascal. The gas inside the balloon heated until the pressure reaches to 450 kilopascal. During the process of heating, the pressure of gas inside the balloon is proportional to the cube of diameter of the balloon, and we have to find the final work done by the gas. Here one thing keep in the mind that when heating process take place, pressure of gas inside the balloon is proportional to cube of the diameter of the balloon. So I hope you understand till now, and if you have not understand, please go back and understand. If you understand this question, then it will be very easy to solve this problem. So let's go for the solution. Here initial pressure and initial diameter, final pressure is given in the question, and also pressure is directly proportional to cube of diameter of a spherical balloon is also given. And we know friend, volume of a sphere is 4 by 3 pi r cube, and when you replace radius in terms of diameter, then we will get pi by 6 dq. Since pressure is directly proportional to cube of diameter of a spherical balloon, so pressure per unit diameter cube will be constant, and from this we have derived this formula. Now here we will calculate the final diameter after the heating process of a spherical balloon from this relation, and here after putting these all value we are getting the final diameter which is equal to 1.44 meter. After the heating process, diameter of a spherical balloon will definitely increase, and here we are getting diameter which is equal to 1.44, and it is greater than the initial diameter. Now you know friend, the area under the PV diagram give the value of work done by the gas, and work is equal to integration of PdB. Here pressure is given in the question, so we have to find the value of dV, and we know friend, volume is equal to pi by 6 into dq. So when you differentiate the volume, we will get pi by 6, and differentiation of d to the power q is equal to 3 into d square into dd. Here this is the value of p from this relation, and this is the value of dB which is equal to pi by 2 into d square into dd. Here this term is constant and pi by 2 is constant, so it kept out from the integration sign, and d to the power 5 into dd is left. Here integration of d to the power 5 is equal to d to the power 6 divided by 6, and the diameter of a spherical balloon is varies from initial d1 to d2, and value of d2 and d1 is known. So here we simply put the value of d2 and d1, and we will get the value of work done by the gas which is equal to 314 kilojoule, which is our final answer. I hope you have enjoyed this tutorial, and if you have any doubt, feel free to ask in comment section. We try to solve as quick as possible. Thank you for watching this tutorial. Have a good day.